All right, let's talk about one of the biggest challenges in cloud architecture. I want you to think of your multi-tenant platform, kind of like a modern apartment building, right? Everyone shares the same foundation, the same pipes, the same electrical grid. It's super efficient, but it also comes with one giant risk. What happens when the person in apartment 4B decides to plug in, I don't know, 1,000 crypto mining rigs, and suddenly the lights start to flicker for the entire building? In our world, the cloud world, this isn't just a hypothetical. It's a critical design question you have to answer.
Because when one tenant's workload suddenly spikes, the first things to feel that strain are the absolute fundamentals. We're talking about the raw compute power, your CPU and your memory.
But oh, it doesn't stop there. All of a sudden, reading from storage slows to a crawl for everyone. The network pipes that connect the whole system together, they get totally clogged up. And just like that, performance for every other tenant starts to tank.
And it's not just the data plane, the resources running the actual workloads. We're also talking about your control plane. The very system that manages the entire platform can get hammered by a single, overeager tenant making way too many API calls.
And this whole situation, well, it has a name. It's called the noisy neighbor problem. And honestly, it's one of the classic challenges you'll face building any kind of shared system. One person's heavy usage, whether it's legitimate or not, directly messes with the experience of everyone else. Now, you might be tempted to think of this as just, a temporary operational headache, something you deal with when an alarm goes off. But it's so much deeper than that. If you don't plan for the noisy neighbor from day one, at the architectural level, it can have really severe consequences for your business. I mean, just think about the ripple effects, right? Your customers start seeing slowdowns. You might even blow past your SLAs. The whole platform can become unstable. It feels totally unfair to your well-behaved tenants. Your costs become impossible to predict, and every little incident turns into this massive, all-hands-on-deck fire drill.
So how do we deal with this? The good news is we're not helpless. We actually have a pretty powerful architectural toolkit at our disposal. As architects, there are really three main levers we can pull to get this resource contention under control and build a much more stable, predictable platform.
So, what are they? Well, it really boils down to these three things. First, you can limit resources directly. Second, you can create strong isolation boundaries between your tenants. And third, for those really big customers, you can dedicate infrastructure just for them.
Let's start with tool number one, resource limits and quotas. This is your absolute first line of defense. It's where you get explicit and you set hard caps on how much CPU, memory, and I/O any single tenant is allowed to use. You can even get clever and define different limits for short bursts of activity versus long-term sustained usage. Okay, tool number two is all about isolation. I want you to think of this as building virtual fences around each of your tenants. You can use things like namespaces or separate cloud projects to put them in their own little sandboxes. You can isolate their network traffic, even their access to the control plane. And you get to choose how strict those fences are, from a soft suggestion to a hard, unbreakable wall. And our third tool, well, this one brings us to a really fundamental choice in the infrastructure model itself. On one hand, you have shared infrastructure. It is fantastically efficient, way cheaper, but you always have that risk of noisy neighbors. On the other hand, you have dedicated infrastructure. It absolutely guarantees performance and gives you total isolation. But yeah, it's going to come with a much higher price tag.
So that's the theory. But what does this look like when all the pieces come together in the real world? Let's walk through a quick example. Let's imagine we're building a SaaS analytics platform. Okay, so a brand new customer signs up. We start them off in our efficient, shared resource pool with everyone else. It's cheap, it's fast. But as their business grows, their usage grows, and eventually they start bumping up against those resource quotas we set. At that exact moment, our automation kicks in and seamlessly migrates them over to their very own dedicated pool of servers. Now their heavy workload can't bother anyone else.
Now that whole automated life cycle we just walked through, it sounds pretty amazing, right? But here's the thing. It relies on one absolutely crucial component. None of these controls, none of these limits, none of this automation works if you're flying blind. You have to have amazing monitoring, true observability, to see what every tenant is doing in real time. It's simple. You just can't control what you can't see.
And that brings us to the final and maybe the most important part of this whole discussion. There is no single right answer here. There's no perfect model. Designing a great multi-tenant system is really a balancing act. It is full of trade-offs that you, the architect, have to make.
And here's the first core trade-off you're always going to be wrestling with. Are you optimizing for efficiency? Are you trying to pack as many tenants onto your hardware as you can to drive down costs? Or are you optimizing for isolation, guaranteeing that rock-solid performance for every single customer, even if it costs you more?
And the second big dilemma is this constant tension between simplicity and customization. Do you want to build a simple, one-size-fits-all platform that's super easy to manage? Or do you want to offer premium tiers with all those dedicated resources, which adds amazing features for your customers, but also adds a ton of complexity for your ops team? So to help you navigate all this, let me give you a few common traps to avoid. First, do not rely on trust. Enforce limits. Second, don't treat your free tier users the same way you treat your biggest enterprise customer. And be really careful not to add the cost and complexity of super strong isolation too early, or even worse, making it a one-way door that you can never go back through.
So I'll just leave you with this question. Take a hard look at your own architecture. Have you intentionally designed a quiet, predictable neighborhood where everyone has what they need to thrive? Or are you just running an unpredictable block party, constantly one noisy neighbor away from total chaos?